The new science results from Juno really are our first look at close up at how Jupiter works. And so the first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different. Jupiter's poles are covered in these cyclones and anticyclone storms, some of them half the size of the Earth or bigger. And we're puzzled as to how they could be formed and stable in that configuration. And the North Pole doesn't look like the South Pole. And so we're questioning, the scientists are really questioning whether this is a dynamic system and are we seeing just one stage and over the next year we're going to watch it disappear? Or is this a stable configuration and that these storms are circulating around each other? So Juno's original objectives really were to understand how Jupiter formed, and that would help us understand how planets general form and how the whole solar system was made. What we're finding is that actually we didn't understand giant planet dynamics very well, the whole atmosphere or interior structure. So the next pass close to Jupiter is July 11th, and we're going to go right over the Great Red Spot. And that's really going to be the first time that we get a close look at that and to see what it's like underneath the top surface layer. I mean, how deep are the roots to that? That's a 300-year-old storm. A lot of scientists believe that the roots must be very deep. Well, when we go over with our microwave radiometer, we're going to see, is it the same as the zones and belts, or is it very different? And nobody really knows.
What we've seen so far is exciting, no question about that. But it's like a puzzle, and we're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet. The Juno mission is unique because it's the first time that we've ever gone in a polar orbit, which goes from pole to pole, over the North Pole, through periapsis, and under the South Pole. All the other missions we've done and all the observations we made from Earth were made from the equator. And you don't see the poles very well if you're sitting on the equator. Yes, this is the first time we get the first clear, unobstructed view of what the aurora looks like and what the polar phenomena looks like. And at the same time, we're flying through the magnetosphere right above the aurora, so we can sample in situ the charged particles that are precipitating down magnetic field lines, the guys that are exciting the emissions that we see. This is the first time we've ever been able to do that. If you think about the Earth's magnetic field, it's generated deep inside the planet. So when we measure it just above the Earth's surface, it's very global in nature. But if you were to measure the field down near the surface of the dynamo, it would be very lumpy, a lot of spatial variation. So when we fly over the surface of Jupiter and we find that the field is pretty lumpy, that indicates to us that maybe the magnetic field is generated by a dynamo that's much closer to the surface than we had anticipated. Jupiter's got enormously intense, omnipresent aurora. We see it in ultraviolet, which are wavelengths a little shorter than we see with our eyes. We see it in infrared, which are wavelengths a little longer than we see with our eyes. You can also see some visible aurora on Jupiter. But it's immensely powerful, and it appears to be excited quite differently from the Earth's aurora.